Things I'd like to say for this one, the prerequisite that's quite required in order to understand this is to know elementary operations and how to reduce a matrix to a more reduced form where we have zeros going from the left side as we drop in rows. So the lower the row, the more zeros there should be from the left side, and below the most left entries of each row, there should be zeros in the rows below in that same column, and left of the last to the left entry should be only zeros as well. So we'll just transform it a bit. The matrix, we will rewrite it using the elementary operations a bit. So I'll add the first row to the third row. So I can have 0, 2, 3, 1. I added twice the first row to the third row. The second one and first one we simply keep same. That one we didn't change at all in this step. And now we see second and third row are same. We can subtract, for example, the second row once from the third one. So we'll get a 0, 0, 0 situation, only 0 situation in the last row in the bottom. So we'll have 3, 2, 1, 1 left up here, 2, 3, 1, 1, and 0, 0, 0, 0, 0. Alright, and the main point of this one is to learn one thing. And that is the entries that are right here at the end. What specifies them, they're called pivots. They're called pivots because we have zeros below them, and the most left entry in the matrix, such that there's only zeros further left from it. In the case of the first row, the 3, there's no zeros, there's no more entries, so there's no zeros left of it, but there's no more entries where there could be zeros anyway. As we go down, by the way, and as I said, this is definitely recommended to know beforehand going to these considerations and this further knowledge, but when we're doing row operations, one of the very basic ones is to exchange rows. You're free to do that, to switch rows. So if, for example, we got this 0, 0 in the middle, we could always switch it, right, around. So if you sometimes don't get the pattern, you can get it by switching the rows at least. If you've already been doing row operations by subtracting one from another, or multiple of one from another, or multiplying the whole row by some multiple or something, you eventually get to a point that it could look like this, but just the rows are switch them around such that it looks in this manner. The rules are, as I say, there's zeros below that last to the left for each row, there's zeros below the last entry, and every next entry is going to have more zeros from the left side. And so that so-called leading entry, this pivot right here and right here, well, it's tied to the column that it's located in. So we see in the first column we do have a so-called pivot, in the second column we do have, but because the third row only has zeros, it doesn't have any more space to offer us one. So if this represents x1, this column x2, this one x3, for x1, x2 we have pivots. For the x3 we don't, because we got for x2 and x3, the third row does not offer more information. And that means that because x3 doesn't have a pivot in its column, that x3 will be a so-called free variable and it will become a parameter. Alright, so if you're looking for, and this can be bigger systems as well, for which variables will become parameters, it's those that when you reduce it to this kind of form, it's those columns that do not contain this pivot, that don't have that leading entry, the one below which there are zeros, and that moves right with its row. But of course, first, definitely important to make sure that the matrix is in that proper reduced form, at least to a sufficient extent. And for example, if the second row was multiplied by a constant multiple in all of its entries by 2, it will still have a pivot. That value would be 4. Alright, it could be multiplied by 2 or 5, it could be a value of 10, but it still would be a pivot due to its location, due to zeros being below it, 0 being in its row, zeros being in its row left of it. Alright, so for that reason, x3 doesn't have, the third column doesn't have a pivot. That means that x3 that's represented by this column is a free variable, and we will treat it as such when now further solving the system. So now we can get the constants back out of the matrix, can start solving it with this in mind. Right, so this applies for bigger systems as well. We can have more parameters. So if you have another column that again doesn't have x sub n, x sub m, for example, we had x sub 3, or for example x sub 5 or something, then that x sub 5 we will call another letter, perhaps s or some other letter, alright, so another parameter for that other column. Here we happen to have one parameter, one column that doesn't have a pivot, so that one gets to be the parameter. Alright, so let's now use that to solve it. So this second row that does have information tells us that 2x2 equals to 1 minus, just taking the coefficients from the matrix, minus 3x3. We said x3 is t, so it's minus 3t. So x2 is going to be, and using the first row, we get this, but that translates to this, which is this. And so now we got the value for x1, we got the value for x2, and x3 is t itself. So if we want to say what's x1, x2, x3 as a general solution to this system, it will be this 3 entry vector, of course, where x1 is 2t over 3, x2 is 1 minus 3t over 2, and x3 is directly that t. And furthermore, I mean, this is of course t ranges in real numbers, so any real number multiple can be put behind t, alright? And we can rewrite it furthermore. We can say that this is t times 2/3, you know, just isolate out the t, minus 3/2 and 1, and add the constant remainders. For the first row there was just t, in the second row we have 1/2, and third row we have again 0. Alright, so we see the solution for this linear system will be a line that goes through this point, and then it has the direction of this vector. So you go through this point, then you continue through that point or until that point in the direction of this vector at any real number multiple of it. Alright, so this represents all the points of the line that's the solution to this system. And the main point here to take away from this is that how do we find which variable in that system after having the matrix, you know, we had started out with this augmented matrix with the row operations, which one will become the free variable is the one that doesn't have the pivot, right? That means the variable represented by that column that doesn't have a pivot, because the first two they have it, in this case the third one didn't.